Manufacturers of autonomous vehicles require approval from transportation authorities. Before the car leaves the factory, an EOL test checks all functions for proper operation. But what happens to these vehicles after they've been on the road for several years? How can we ensure ADAS functions work properly over a vehicle's lifetime? A straightforward and safe approach is to enhance regular periodic technical inspections to check not only the standard vehicle functions, but also the ADAS functions and sensors. A PTI has 4 layers. First, visual inspection, software, static test, and the 4th is an effectiveness test. Visual inspections and software checks have historically sufficed for conventional vehicles. However, safety systems in the automated vehicles of tomorrow will require static and effectiveness tests for safe operation over their entire service life. Together, DEKRA, AVL Die Test, and Rohde and Schwarz have developed the solution to verify radar sensor performance during a PTI. In this solution, the vehicle's radar sensor sends signals which are then modified and returned with a delay. Modification is achieved through a compact radar target simulator in the PTI setup. The sensor perceives the artificially generated signal as a real object. This method is now used to precisely validate sensor functionality during the PTI. Let's take a closer look at the extended PTI tests for ADAS functions. Third, static test. Here, each sensor is tested independently. First, the sensor undergoes a power measurement, making it possible to quickly evaluate the environmental influences that degrade radar performance. The next step is to assess the function of radar-based safety-relevant features such as AEB, ACC, and BSD. The radar signals presented to the sensor are read out from the vehicle via the PTI interface and compared with each other. The functionality of radar-based features can be assessed using this method. Test cases are configurable. Users can choose from fast-moving vehicles, large objects, and even vulnerable road users, such as pedestrians or cyclists. The test system's size and flexibility makes for straightforward installation in any PTI station. It can also be easily localized to national standards. For vehicles with higher-level ADAS features, a more comprehensive approach might be applicable. Fourth, effectiveness test. This test not only assesses each individual sensor, but also a set of different sensors and sensor types. Depending on the corresponding ADAS feature set, different sensors and sensor types must be stimulated at the same time with consistent information. This method verifies fully autonomous driving functions such as highway pilot during a routine PTI. The solution test extends a PTI to include ADAS safety tests for safe operation throughout a vehicle's lifetime. In summary, static tests can be seamlessly integrated into a current PTI. This means that we can test the safety of driver assistance systems in a PTI with a cost-effective, safe, quick, and user-friendly process.